Hi, doing a quick video on half-life. Yeah, there it is, half-life. It's going to be awesome. Okay, so check it out. Half-life, the general equation for half-life is this. A of t, so some amount of, with respect to time, is equal to A naught. That little zero is a naught, so we call it A naught. Times 1/2 to the t over h. So what are each of those? A of t is the final amount. Final amount. A naught is the original or the initial amount. T is respect to time, typically in years. And then we have h, or half-life, of some substance. So most substances have a half-life here on Earth. And so we can figure out how long ago they were around, and some other things that a scientist will be happy to explain to you, or myself, because it's kind of cool, actually. Here we go. Example number 1. It says, hey, plutonium-240 has a half-life of 6,563 years. If the initial amount is 78 grams, how much will be left over after 15,000 years? So plutonium has a decay rate of 6,563 years, and it will be half its substance. So let's first think about the concept. What are we doing? We are looking at 15,000 years and saying, all right, how much is left after 15,000? So remember, every 6,563 years, it loses half the substance. So if it starts out with 10 in the half-life years, it will go to 5. And after that, it will go to 2.5. And after that, 1.25, and so forth, and so forth, and so forth, until there's almost absolutely none left. So it's negligible at some point. So what we have to do, think about, is, well, there's at least 2 half-lives, because 6,500, well, 6,000 is 12, so we're talking about 13,000 years. So, but we're going 15, so we're going a little bit more than 2 half-lives. Well, if we took the first half-life, we take 78, divide that by 2, that's 39. So now we got 39 grams. If we look at the second half-life, another 6,500 plus years, then we should be down to 19.2. But we're going beyond that because we're going more than 13,000. So we're at 15,000. So we should estimate that our answer, when we calculate it, will be less than 19.5 grams. All right, well, let's do the calculation and see if we're right. So we calculate A naught, 78 grams. T, 15,000 years. H, 6,563. Plug this into your equation. There's your A of 15,000 equals 78 times 1/2 raised to the 15,000 divided by 6,563. And what happens is A of 15,000, you plug that in your calculator, what do you get? You get 15.998 grams to 3 decimal places. So we were right. 15.9 is less than the 19.5. So that's good. We should have had less. So our answer makes sense. All right. Example number 2. Let's slide over here a little bit. All right. Next one says, scientists found that the current mass of an ancient piece of wood, found it somewhere, it was dug, it was very deep, it was somewhere, and it was 134 kilograms, the current mass. So they dig it out, and they're like, wow, cool, here's this cool piece of wood, wonder what it is. They look through it, and they figure out that it has something to do with the ancient Egyptians. And they know carbon-14, which is found in wood, has a half-life of 5,730 years. So the piece seems to fit with an ancient wooden boat made by the ancient Egyptians around 3100 BCE, before current era. So find the mass of the wood at the time. So how heavy was this thing when they built it? That's what we want to look for. All right. So we know the final because we've gone in time. We're now here. So the final amount is now. What was it back then? So really what we're looking for is A naught. We know A of t. We know t is, well, 3100 to get you back to 0. And then we're 2017 plus, right, ish. We're more than that. But I just based it on 2017. So you add those together, and that's 5,117 years the thing's been around. Half-life, 5,730. So what should we expect? Now, put your thinking caps on and think about this further concept-wise. Would we expect more than half of the existence of the piece, or would we expect less than half? Well, let's see. Here we go. 134 is equal to A naught, because we don't know that, times 1/2 to 5,117 divided by 5730. And you can take all this and put it in the denominator, right? So we get 134 kilograms divided by 1/2 to the 5,117 divided by 5730. And when you get that, you get 248.85 kilograms. Now, ask yourself this. Is that double the time, the 134? Is it double, or is it slightly less than double? What should you expect your answer to be? All right, think about the context of the question and go from there. Does it make sense? It needs to make sense, or something has gone awry. But I think you're on the right track. Anyway, hope you have a great night. Thanks again. That's Half-Life. I'm out.